Today's edge is just where the edge is, and everything moves to a data center that is often very far from the edge environment. So what we end up doing today is we end up sending all the data to a data center, and this data includes video, file, JSON data, CSV, machine learning models. Everything that is done at the edge goes to the cloud, and we do the computation in the data center. And then all the decisions, the analytics, the file data that we need, the ML models, all the control decisions come back to the edge. And so we can summarize the current problems at the edge is that we have a distributed data network. The edge is very distributed with very different number of components, but we don't have a unified view of this data to make the control decisions and make the decisions that are important. So everything has to go to the cloud. These edge nodes are composed of proprietary software and they're built on legacy systems. And so we have each company is essentially building their own system and their own solution. We with EdgeLake are building the edge data fabric where your edge devices, so your cameras, your charging stations, your oil rigs, they send data to an EdgeLake node. And this EdgeLake node is composed of data services. For example, AKAVE and FILECOIN for object storage. You can enable SQL services for like Postgres for database management solution. What the key important part is that all of these services are enabled via a virtualized edge data fabric enabled by EdgeLake. So when applications don't need to know where the database is, they don't need to know where the object is. All they need to do is send a request to the edge data fabric, and EdgeLake will execute the query and return the result back to the application. All you need to do is send the data to the edge data fabric, and EdgeLake will return you a unified result of all your data, no matter where it is and no matter the distribution. And once you have EdgeLake Core, you can start enabling services like database services, PubSub services, blob storage services, and all these services are essentially abstracted to appear like all the nodes. So all your EdgeLake cluster appears as if it's one physical machine. So you don't need to know where your data is. EdgeLake or the Edge Data Fabric finds where your data is and returns a unified result very efficiently. Our current approach to store objects was that we store all the objects on the local file system of each EdgeLake node. The storage rapidly gets exhausted on the EdgeLake nodes. And so what we need is an edge native object storage solution where we don't have to send the objects to the cloud. We can keep them at the edge and we can access them when we need to. So this is where Akave comes in. So we can deploy Akave anywhere. With all of this combined, this is the edge data fabric. So notice now that we have our edge ecosystem, you can define rules in EdgeLake and say, I want to offload all my video files to this Akave service. And Akave here will manage all the objects for you dynamically. And when you want the object back at the edge or back to EdgeLake, all you do is you send a request to EdgeLake. EdgeLake sends the request to Akave, and the data comes back to EdgeLake. So Filecoin is the archival storage. Filecoin is when you don't necessarily need the data at the edge anymore, and you want a cheaper solution to manage this data. And so through Akave, you can offload your data to Filecoin via archival storage. So Filecoin is the AWS Glacier, and Akave is quite similar to your S3. And so with this edge data fabric, you get an end-to-end lifecycle solution. So your distributed data network now has a unified data view with EdgeLake. There are no central dependencies. EdgeLake is resilient to a failure of an EdgeLake node because the system is highly distributed and there's availability you can add on top of your EdgeLake cluster. You can set up object storage anywhere and at any scale. So you can dynamically provision more Akave instances at your edge to manage all your object storage, just like you can deploy more EdgeLake nodes to manage more data in a database or in other data services. Your ingress and egress costs are also fixed. Because you're only operating at the edge and within your network, you don't have to pay the ingress and egress costs. So that's a significant cost reduction. And the scalability now becomes horizontal. You just plug in more machines, plug in the plug and play software, more EdgeLake instances, and you can scale horizontally now. So I'll transition now to what we are going to demo. And so this entire setup is composed of Postgres. We now store the data on Akave, and Akave offloads that data with retention based on retention policies to Filecoin.